Okay, so we're going to be doing system of equations. I'm just going to give you a brief introduction today, and then tomorrow we'll go more in depth into what we need. So I'm playing with my internet, so you're going to be patient. Okay, so system of equation, you're going to have at least two equations, sometimes more. The more variables you have, the more equations you're going to need. So here we have two variables, so we have two equations. If I had three variables, I would need at least three equations. Graphically, it means you, first of all, graph, right? So the first equation starts at -3. The slope is 1/2. So I'll go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And you could go backwards, and so on and so forth. I hope we know how to graph. If you don't, you need to come see me for help. So, let's see if we can draw a nifty little line here. I guess it would be a double arrow. And we try to be good. I thought it would make it prettier. It is not my fault. Okay, anyways, go with that. Now we go back to our little dots. Now the second line starts at 4, and my slope is all blessed. We don't need that. Hold on. Oh, well, darn blurmit. I guess that would be that option. Okay. There's just a big dot now. So you start at 4, and then you're going to go up 4, 1, 2, 3, 4, and right 1. You would also go down 4, 1, 2, 3, 4, and then down 1. 1, 2, 3, 4, and then... Okay, notice that at that point, if you want to draw your line, you can. Okay, that at this point they intersect. This is your solution. And I don't know how to get it off of the dot thing. Okay. Solution. Woohoo! So, that would be at -2 because that's your x value, and then -4 because that's your y value. So the solution to my system of equation is -2, -4. And we get happy. So that's how you find a solution graphically. We'll talk more about how to do it algebraically later on. But I wanted you to be able to see what is really happening. Now, there's 3 types of systems. There's an independent system, very much what we just talked about. It has an intersection. It intersects. That means they will have different slopes, and probably different intercepts or y intercepts. My brain died. Sorry, y intercepts, but it's not guaranteed about the y intercepts. But different slopes are a definite. The next kind are called dependent. It is the same line. That's why it's dependent. Where one line goes, the other one. You can think about a married couple. They're dependent upon each other. Where one is, the other is. Two become one kind of situation. That means when you solve for y, they will have the same slope and the same y-intercept. Okay? Their solutions are infinitely many. Okay? So now we are going to talk about inconsistent. Inconsistent means there is no solution. Okay? They're parallel lines, so they have the same slope. And different y-intercepts. Okay? These are people that never meet. They will never see each other. When is it actually used? Well, that's a pretty good question. It's very applicable to real life. This is an example right here of looking at two cell phone companies and how much minutes you are compared to the money, and when is it better to go with one company versus the other, depending on how much time you actually use your phone. The chocolate example also, a lot of systems goes into inequalities and things like that that you'll need to know later on that can help businesses. It is highly applicable to life. It can help you find one thing or two different things that depend on each other, such as like ticket prices and the number of tickets sold. So it is applicable to life, and I hope you actually get something out of this week as we go over it.